All right, I think we're ready to go. Cool. All right, so thank you guys for coming. Yeah, so on my way here, I was just at my hotel about 5 minutes ago. I walked here down the street. There's a guy in the corner preaching from the Bible or whatever. My goal is to be better than that. So it shouldn't be hard, exactly. I come from a place where it never happens. All right, so I made this slide when Doge was cool. It's not very cool anymore, but you're still stuck with the slide. So yeah, so I originally wrote this talk in a very primitive form for B-Sides Quebec about 6 months ago. Was anybody here at B-Sides Quebec by any chance? Perfect, I can reuse the jokes. All right, so I'll start with a quick story just to break the ice. So I like I said, I did this talk at B-Sides Quebec in a primitive form, and I've been living in California, working at Google for about the past year or so. And in California, there's no rain. It doesn't rain there ever, and I'm told it's a bad thing, but I love it. The problem is, I wanted to go back to do this talk. Bringing a jacket didn't really occur to me. So I'm staying about a mile from the conference venue. I have no jacket, and it's pouring rain. So I ended up doing my talk soaking wet. Wow. So I ended up doing a whole talk soaking wet. So that was hard mode. Today, easy mode. And also, B-Sides Quebec was all in French, except for my talk. So I'm actually not sure anybody actually knew what I was talking about anyway. All right. Je m'appelle Ron Bos. I got my grade 6 French, and that's about it. J'ai 31 ans. Est-ce que je peux aller aux toilettes? And that is it. All right, so you all know the slide. I'm here to talk about my own tool that I wrote in my own time. I work at Google. They have nothing to do with this. I haven't even shown them the talk yet. I'm going to show them afterwards when they can't say no. Oh, is this being recorded? Oh, crap. But seriously, the reason that Google encourages us to do these presentations and talks and stuff, we are recruiting. We need good people. We always need good people. And it's really hard to find. So if you're ever interested in a job at Google or pursuing a job, come find me. I got a stack of business cards somewhere. So yeah, that's that. So what I'm going to talk about today, I'm going to talk about how to use DNS in pen testing. Basically, everything I talk about will be about how to use DNS in the way it was designed to be used, in a sense. That is, I'm using the protocol the way the protocol was written, not taking advantage of vulnerabilities or certain version of Bash or anything, or Bash, still stuck on Bash, certain version of bind or anything. This is just general protocol specific stuff. So I'm not going to talk about poisoning, misconfigurations, stuff like that. It's just beyond the scope. So a quick crash course on how DNS works. I'm hoping most of you know this to some extent already, but I'll go over it anyway. So a recursive DNS request starts with somebody sitting at their computer typing in, typing something into their browser. In this case, we use dig as an example. So dig tests the skullselectlabs.org, skullselectlabs being my domain. It's going to go to your router, probably. And your router's going to say, is it cached? Nope. If it's not cached, send it on to the router's DNS server. So that's going to be, for example, 888 Google server or whatever's configured. It might go through your ISP server, it doesn't matter. At some point, it's going to go up to the root servers, and the root servers will do the same thing. Is it cached? Yes, no. If it's not cached, go to authoritative server, which happens to be mine. The authoritative server now gets the request and sends back whatever it wants. So what's interesting is that the end user, the person typing in the request, never actually sent me a packet. A packet never went from the victim machine to my machine in any direct sense. Yeah, I'll talk more about that after. So that's a very quick introduction to what matters. There's lots of other stuff involved, but it doesn't matter for this. So there are lots of types of requests. There's some listed here, but I'll talk about a couple of them. An A request gets an IP address. You send an A request for google.com, and you get back, in this example, 5 IP addresses. A quadruple A request gets you the IPv6 address. MX gets you the mail records. The one interesting thing about mail records and other records is that these are text. It's not just 4-byte IP address or a 16 whatever byte IPv6 address. It's actually text, which is useful to us We'll see why for obvious reasons. There's also CNAME, TXT records, NB, NetBIOS stuff. CNAME, much like MX records, are text, which is nice. TXT records are designed for text. Basically, you can send a chunk of up to 255 bytes of arbitrary data, unless you're using Windows as libraries, in which case you can't have nulls for some reason. And that was annoying troubleshooting, which means you need encoding of some sort. That's cool. So straight from RFC 1035, this is what the DNS packet looks like. It's got an ID value, and then I'll map it to what it looks like in a dig output. You got the ID value. The ID is a random value that changes for each request, and is basically used to know when you're getting a response for which request. Asynchronous, blah, blah, blah. The opcode can be query or a couple other things. We'll just worry about queries. The flags, we got actually 5 flags. There's a QR on the left there. Then there's AA, TC, RD, RA. So QR means it's a query as opposed to response. AA means authoritative, TC means truncated, RD and RA are recursion, desired, allowed, whatever. Return code, then questions, answers, name servers, authorities, additional, blah, blah, blah. So that's a full DNS packet in a nutshell. The 4 things at the bottom are a subformat called resource records. A resource record looks like this. So an A record, a quadruple A record, an NX, an NS, MX, TXT are all in this format, roughly. So they all start with a name, which can be any amount of length, the type, the class, time to live, and then the length in the data field. And the data is going to be different depending on which of these request types. I realize it's all kind of boring protocol stuff, so I'm going to get through it fast. So a bit of an aside, record compression. I mentioned how the answers have a name. If you have like 5 IPv4 responses, like I showed you on the previous slide, it's going to have the same name repeated 5 times in the packet. And DNS was invented in, a million years ago when bandwidth was actually mattered to some extent. So what DNS did was they invented this compression scheme where if the name starts with 2 1 bits, so C0 typically, it means the name is stored elsewhere in the packet. So please look at this offset in the packet. So C00F means please look 15 bytes from the start of the packet, and that's what the name is. Now, oftentimes that name can also be a pointer. So you have C00F, and then at address 15 you have C00F in an infinite loop. And that's happened in a lot of DNS libraries. And MEP, for example, had an issue with that initially. So yeah, DOS is fun. So this mirror screen thing is annoying me. I'm gonna close this. There we go. Okay, so reverse DNS works basically the exact same way. The only difference is it uses a record type of PTR as opposed to MX or A or whatever, and it formats the IP address as basically backwards. So to get 74125.226.5, you reverse it 5.226. It's just the way it works. What's interesting is that just the same way I control my records from my domain, I control the reverse records from my domain. So if you do a lookup for my IP address, which is 206.220.196.59, you'll get test.scalsalabs.org returned. That can actually contain punctuation. Apostrophes are valid in DNS, or angle brackets and stuff like that, which is kind of interesting, and we'll cover that briefly in a little while. So let's start with some recon type stuff. So as I said, the best part about DNS is it's allowed off every network ever made, which is cool. I actually tried running a server without DNS once as a security feature, and it was just an absolute failure. You can't update, you can't, most SSH connections will not time out, but will take longer. It's just annoying. So most traffic gets blocked, DNS traffic gets to the router. Most traffic is monitored by IDS, IPS type stuff. DNS traffic, chances are still monitored, but it's probably ignored for the most part. So here's kind of the scenario. I personally own sqlsalabs.org. Like I said, it points to wherever I want it to point to. Right now it's a DNS cat server, but I can change reverse record to forward records, whatever. What can I do with it that's interesting and fun? So cross-scripting and log files. So one thing that's fun, set your user agent to image source equals blah, where blah in this case contains some unique identifier .sqlsalabs.org. What's going to happen, I think, yeah. So what's going to happen is that the admin at some point is going to view their logs, and they're going to see this, and it's going to render in their browser. And you're going to see a request to your DNS server and go, hang on, that was, xyz.com was vulnerable to this injection. I can talk about this as of last week, so I will. Red Hat Satellite Server is a tool for managing your network. It's basically you connect all your servers to it. It pushes updates, pushes code, pushes patches, all kind of stuff. It's, I was reviewing it for fun because that's what we do. I was reviewing Red Hat Satellite to see if I could find issues, and I found that cross-site scripting on the admin page, exactly this. And what happened is that anybody who has network access to the server could plan some stored cross-site scripting using exactly this, using the user agent, using 404 error, whatever, into the admin logs. And when the admin later viewed the logs, it would run in their browser. Now, being the fact that this is a server management tool, cross-site scripting in your browser means code execution on every server in your network. So I went to Red Hat with this and said, hey guys, you gotta fix this. And they said, oh no, it's cross-site scripting. That's moderate. We don't fix those. And I went, I spent 9 months going back and forth with them. I eventually made a video, which I'll make public on my Twitter feed at some point soon, and sent them the video of saying, here's how I own the network using Red Hat Satellite Server. And they came back and said, okay, we'll fix it. Here's a patch, and here's patches and we'll do patches for other cross-site scripting as well. So a policy change was a huge victory in my opinion. So it's been patched. If you run Red Hat Satellite Server, make sure you patch yourselves. And I'm going to release the POC in a couple days, or sooner or later. I can now, that's the main thing. So anyway, this type of a check and logs can actually work in this particular case. All right, so in that situation, let's go kind of through step by step of what exactly I mean by cross-site scripting and logs. So the admin is going to go to the vulnerable server and send an HTTP request. It's going to return the HTML that we use as a user agent because they said, show me all the user agents. And they said, oh, look, we have a user agent called image source equals blah, blah, blah. They're going to say, hang on, this is an image. I need to load it. So it's going to do a request to load the image, first making a DNS request. I'm going to respond and say, never heard of it. And all right, so the image doesn't load and life goes on. To somebody who's doing incident response type stuff, if you see IP address and logs and you try to ping it or you try to do an NS lookup and it says host not found, what are you going to do? Are you going to say maybe there's some evil DNS server who's tricking me into saying the host is not found? Or are you going to say oh, this is probably just nothing? Chances are you're not going to follow up on it. And that's why this is kind of cool. So just repeating myself a little bit. We care because the packet captures look completely innocent, more or less. You see DNS requests going to your DNS server. That's okay. We're not connecting off the network, so firewalls don't care. And it's stealthy as heck. Yeah. So basically, we can tell when the service wants to make a connection without the connection ever succeeding or being logged. So that's cool. Email. So if you want to see if anybody's trying to email you without actually letting it get through, I don't know if this is even a reasonable situation. It's just something I thought that would be kind of cool. So I stand up my fake DNS server. DNS Logger, by the way, is a very, very simple DNS server I wrote. It's written in C. You basically tell it what to respond with to everything, and it responds with that. So you see, respond to everything with 1, 2, 3, 4. They respond to everything with 1, 2, 3, 4, and log everything. You can find it on my GitHub page, which I'll link at the end. It's part of NV tool. Anyway, I put an IP address in, or sorry, I put an email address in, admin@mydomain.org. I press check address. This is simply some tool I found online. And it says, oh, domain's invalid. Don't worry. Once again, to somebody who's trying to email you, they just see an immediate failure, and they think, oh, it's a failure. Gone. But what I see is someone's trying to use this email address in some way. Is that interesting? Maybe not, but whatever. Searching for Sql injection. So these commands I've never actually tested, but it seems logical to me that these would work. So your mileage may vary. Anyway, I was looking up commands to cluster servers in both SQL Server and MySQL, I think. Yeah, first one's SQL Server, second one's MySQL. And these are both commands that should, in theory, cause a network connection to attempt to be made. And once again, all I'm looking for is the server vulnerable, yes or no? If it attempts a network request, it's vulnerable. If it doesn't, it's probably not. At least to, root level of SQL injection. if you have a non-root user, it's not going to work as well. So speaking of those types of paths, XXE is awesome. So about, when was this now? It was a few months ago anyway. Detectify wrote a blog post. So part of my job at Google, to rewind, is our vulnerability rewards program, VRP. You guys find vulns in any of Google services or anything that we run basically, and you submit it to us. You know, I found cross-site scripting on Gmail or whatever, and we say, you did, here's money. And it's great because we don't have to hire more researchers, and it's also great because we find the vulns thanks to people like you. So it's really cool. But anyway, Detectify submitted an XXE vulnerability. What XXE is XML External Entities, which means whoever wrote XML decided it'd be a good idea, and maybe it was a good idea, to be able to include other files in your XML. So you could say, in my XML file, I want to include /etc/password as a file. And you know that works in XML and it returns the file to you. If you read the Detectify blog, you'll see a screenshot censored of Google's add Google etc/password file. So that's pretty cool. It's a really neat attack actually, and you know, after this blog got posted, we got about 20 more of them of various quality. So yeah, it's a neat attack. You know, arbitrary file read off servers. So what if you use this? XXE file :/etc/password. What it's going to do if this is vulnerable, if the XML parser is configured wrong, it's going to try to read /etc/password and include this in the XML file. And this might work if that file exists and if XML is configured that way and such. It might not work. It might be vulnerable to it, but the file doesn't exist, so it just doesn't work. You can also include files for remote servers, and I saw this a lot when people were reporting vulns to us. People saying like fetch http://google.ca. It's kind of cool. Yeah, so you know, I'm sure you can see where this is going. So because we can ping other servers, rewinding for a second. So you can include google.ca or some other domain, any web page on the internet you can include in there. And if there's a firewall, it might not work. If there's, if something is weird on the server, it might not work. What will work, however, is the DNS lookup. So you say, do a request to http://mydomain.org. And once again, if there's a firewall, a weird file system, the file's never echoed, blah, 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 you can still detect this. That's kind of cool. Recon with DNS. More people should be doing this. I think I have lots of time. Yeah. So a quick side note about Gopher, the Gopher protocol. Unlike HTTP, Gopher has very little overhead, which is cool because it means you can send basically arbitrary strings to a server via Gopher, whether they be exploits or whatever. And this is copy and pasted and obviously censored from a real world pen test we did a long time ago. We found an XXE style vulnerability on the server. I think a remote file include, but it's relevant. And we use that to fetch Gopher :// localhost port 25. The big A just tells Gopher something, I don't know. And then the rest we put SMTP, HELO, new line, mail from test@test.com, new line, receipt to Ron at whatevercompany.com, so on. And we were able to send an email through the Gopher protocol against the local SMTP server. That's pretty cool. Basically, any kind of attack that requires only a single TCP packet can be compromised through this type of protocol. Pretty neat. I like that. No, actually, the question was, does that require the server to actually run Gopher? And the answer is no, because Gopher, much like HTTP, can be sent to essentially any port. You can say Gopher :/ localhost port 445/blah. And it's going to connect to port 445 and attempt to send a Gopher style request to that port. The port's not going to understand Gopher because, like you said, it's not going to be running. However, the packet was still sent and the response still came back. The fact that the server didn't know how to parse the response doesn't really matter in this case. What it does require is for whatever is fetching the file to actually understand Gopher, whether it's PHP, whether it's XML parser, whatever you happen to be using. And it turns out most of them still do because Gopher's, no one uses it, but it still exists. So yeah, so using DNS to actually exploit this kind of vulnerability is exceptionally unlikely, but DNS can find this type of vulnerability and then you can use this type of exploit to actually do fun stuff. And honestly, you can do a full talk about how to do that kind of stuff with Gopher. I'm sure I've seen one in the past. So yeah, I'm sure you can find it. So PHP fopen, much like XXE, basically older versions of PHP and new versions misconfigured of PHP can open URLs. So you can say fopen http://blah, and it'll open the URL. So if you're ever allowing attacker to control file names, this might work. So once again, it's the same as all the other vulns. You send http:// your domain, and you see, did someone connect to you? Yes. It's vulnerable? No, it's not. It's easy. Shell injection. This is my favorite. And this is the last part of the section. So basically inject an NS lookup or a ping or a wget or whatever you want into every field of a DNS, of a web application, and say, my username equals NS semicolon NS lookup blah, or my password is backtick blah, backtick. True story. I have lots of time left, so I'll tell it. A few jobs ago, I was doing a consulting gig, and I was using Burp Suite, Burp Pro with a scanner, and I was basically given a voicemail server and said like, hey, can you hack this voicemail server? You open it up, it's got username and password, and that's it. It's like, probably not. There might be a Sql injection, and beyond that, there's not a whole lot else. There's no attack surface. So I fill in 2 fields, test. I run Burp Suite and say, okay, do your scan, and it said shell injection in the password field. I said, cool, a false positive. I'll try it myself. So I put in the password field, backtick, ping localhost -c5 or whatever. Takes 5 seconds. Coincidence. So try backtick, sleep 10, backtick, takes 10 seconds. Okay. So I use this basically to copy the code off the server, because I had to see, like, this is a cool vuln, and I had to see how it worked. So it turns out they were using a command line program for password hashing and passing the password on the command line. So, right? So this kind of stuff can happen where you never expect it. Shell injection HTTP headers, for example. So once again, if someone ever tries to do an NS lookup, in their server logs, it's a failed lookup, nothing too sketchy. In your end, you see that, oh, this is vulnerable. Time for the fun part. And I alluded to this just now. I had this slide last night, so sorry if I screwed the syntax. But my user agent from now on is going to be bracket, test, semicolon. Yeah. I was actually going to write a Chrome plugin anyway to basically make my user agent equal to some random deterministic string .sqlslabs.org. But now that this vulnerability is out, I'm going to start doing this instead. Of course, real men do that. In case you don't know, that's a fork bomb. It just DOS is a server. All right, let's look at a couple of attacks. So security is always about boundaries, whether it's code data boundaries, whether it's about network boundaries, whether it's about crypto boundaries. There's always boundaries. There's trusted stuff on one side, there's untrusted stuff on the other side. The thing is, DNS tends to be fairly trusted. If I do a DNS lookup, reverse lookup for 1.2.3.4, I expect the response from the DNS hierarchy to be fairly good because it's from DNS. Turns out that's not really the case. So this is from I captured a flag from maybe about 8 months ago, maybe. And this is some PHP code. So basically, what you're seeing is, actually I have arrows. Yeah. So address equals get host by address. So in PHP, server remote address is my IP address. So basically, do a reverse lookup of my IP address and store it in ADDR. Then do a DNS get record of my address. So get host by address for my IP address returns test.sqlslabs.org. Then it's going to do a forward request for all records for test.sqlslabs.org. So details gets the full records for all of those. And then it's put into an SQL query and SQL injection, hooray. This was originally somewhat tough to exploit because it's an update, and updates suck for SQL injection. So I apologize for a really complicated exploit. But those CDF problems where you look at them and go like, hey, I wrote a tool for this, are my favorite problems. So in this case, DNS logger is great. Like I said, DNS logger can be configured to return any record you want. So in this case, I told it to return a text record of test, quotation mark, blah, blah, blah. What's really cool is this would also work in a reverse DNS lookup. So if they had said, address equals get host by address, server remote address, and then put that into a SQL query, that would still be vulnerable. But exploiting somebody to reverse DNS record is a lot more difficult than forward DNS, but still possible. If you're interested in more of this, I have a blog. I'll post these slides to Twitter and stuff after. The blog at the bottom there is basically an outline of how this attack works step by step. For most of these attacks, I've actually written up, fairly detailed blogs about them. I try to put the links at the bottom of the slides, so feel free if you want more information to check out my blogs. All right, so cross-site scripting through DNS. I wrote about this blog 4 years ago, or I wrote about this on my blog 4 years ago, and I basically set my reverse TXT record to that, which is a domain I own and a JavaScript file I control. And I went to like the top few results on Google for reverse DNS lookup or DNS lookup or something, and all three top sites, 3 out of 3 top sites, and like 5 out of 10 or 8 out of 10 or something. A lot of the sites in the top 10 were actually vulnerable to cross-site scripting via TXT records, DNS records. And somebody this week actually posted the same type of vulnerability to somewhere. My friend linked me to it and said, like, hey, this is really cool, you should use this in your talk. And I said, guys, I wrote about this like half a decade ago. So anyway, that's an attack vector. I actually reported to all the sites that were vulnerable too, and actually one got back to me and thanked me, the rest ignored it, which is typical. But in any case, I retested when I wrote this, and only one of the top 3 sites were vulnerable. I did not report this time because lazy. All right, so Dns Rebinding. This is kind of out of place in this talk, so it's also super complex, and I talk about more than just Dns Rebinding, but I'll go to the example. You'll see what I mean, it's complex here. So, so basically we have a user at the bottom there. He's behind a firewall. There's a trusted service on the left. There's a router that he can go through. There's DNS. On the left, there's the internet, which is just cats, and then the black hat at the top there. So here's the setup. The user, for some reason, goes to my evil page. They go to http://sqlslabs.org/hello.html. It could be in an iframe. It can be in you can tell them to navigate there. You can email them. It doesn't matter. So they're gonna do a DNS lookup for sqlslabs.org, and once again, I control this. So I'm gonna say, oh, test sqlslabs.org. Oh, that's me up there. No, that's 206.220.196.59. He says, okay, so he'll connect to that and navigate around and look at cats or whatever you do on the internet. And then, you can create cookies, you can create a session, you can do whatever you want on your server. Then later on, the user visits your server again, and they look it up and say, what's the IP address again for sqlslabs.org? And this is where it breaks in modern browsers, because modern browsers won't let you do this. They won't let you change the IP address while you're in transit. But maybe they came back the next day or something, and they looked it up again. And this time I say, oh, the IP address is 192.168.0.1. So suddenly you're connecting to a trusted server with cookies that the hacker controls. So I've been asked before, like, is cookie injection actually, is cross-site scripting via cookies actually, does it matter? And I argue that sometimes it does matter, because sometimes you can inject cookies. This is just one way. So they use that session, they navigate around the trusted service. They think they're at some sketchy site, probably, so they probably aren't doing anything like entering passwords and stuff, but there's gonna be session tokens getting set in the browser, stuff like that. The stuff the server does automatically. And once again, this requires that the trusted service is configured in such a way that you can connect to it with the wrong IP, with the wrong DNS name. Sometimes it works, sometimes not. Anyway, later on, the next day, the user reopens their browser and visits the page again, and this time I send them my IP address again. So any cookies that were set, any local storage, anything like that, any sessions are going to go to me now. Chances are, sessions might not be that interesting, cookies might not be that interesting, but you never know. It's worth thinking about anyway. So basically, that was 2 things really, really quick. I used DNS Rebinding to sneak data into a trusted context by switching out my server with the trusted one, and then I did the opposite to sneak stuff back onto the internet. I just want to talk about this mostly because it shows how DNS is kind of strange sometimes. Browsers trust DNS implicitly. If you go to test.sqlslabs.org now and you go tomorrow, as far as your browser is concerned, it's the exact same site both times. Send the cookies, send the local storage, send everything to that site. And it's not necessarily the case because, like I demonstrated, DNS can change. So yeah, let's talk about tunneling. This is a real photograph I took, by the way. All right, so this stuff might all be a little bit simple for this crowd, but anyway, normal exploitation, you compromise a server, you communicate with it, stuff happens. How's that look? A bind shell hits the firewall, reverse shell hits the firewall, hopefully. And HTTPS is great, but it goes through a proxy, and a lot of networks will, that's a common exploit now, so hopefully most networks will detect that. But of course, DNS, this diagram I showed you earlier, most traffic gets blocked, DNS will never get blocked. So can we do two-way communication with DNS? The answer is obviously yes. Why does it suck doing two-way communication with DNS? Let's see. So basically, the first problem is it's a one-way street. The client can connect to the server, but not vice versa. The server can never initiate a connection and say like, hey client, I got some data for you. Can't happen. So what I do is I pull. So the client will say like, hey, here's my data. Do you have anything? Here's my data. Do you have anything? Back and forth, back and forth. If there's no data, it still sends like, hey, I have no data. Me neither. I have no data. Me neither. So yeah, the firewall never knows. I forgot about that. So in an ideal situation, this is what it looks like. If you want to grab the slides and decode this, it's a knock-knock joke for what it's worth. So the client's going to say, hey, I have a TXT record for blah, .sqlcelebs.org, or give me the TXT records for blah, .sqlcelebs.org. This will work just as well with MX records, CNAME records, even A records if you don't mind 4 bytes at a time, which is really slow. So say, my TXT record, or please give me a TXT record for blah, and the server responds, it's blah. And he says, okay, now I need a TXT record for blah. And each time you're sending a few bytes of data back and forth. Sometimes there'll be no data. So say, what's a TXT for nothing? And the server has data cached or ready, so it sends its data. If this was how DNS actually worked, it'd be great. Unfortunately, it's not. So in reality, the client's going to say, what's a TXT record for that? Then without waiting, it's going to send it again. Some DNS stacks will send 2 or 3 requests immediately and not wait for responses, just like fire and forget. Seriously, it does this. Then you respond to the first request and say, oh, it's this. And then it asks you again because it hasn't quite got the response yet. And you respond to the next 2 requests, and it just becomes this like, forget it. It's a horrible, horrible pain. You can tunnel TCP over DNS, which solves a lot of these, but TCP is not designed for such a horrible network, so there's problems. So DNS is super unreliable. Retransmissions are exceptionally common. Drops are exceptionally common. Like I said, a lot of DNS clients and relays will gratuitously retransmit. I'm not sure if I have a slide mentioning this, but some DNS servers will also modify the data. They don't just like forward it. They'll take it, they'll parse it, they'll rebuild the packet, and they'll send it. Which doesn't sound like a big deal, except OSX is not case sensitive, and actually lowercase is everything. So my first version of DNS Cat that I was testing, I used base64 for encoding because I needed no nulls. It turns out that OSX would just take all the uppercase, lowercase, and send it on, which was super irritating because I couldn't figure out why it wasn't working. So I'm not going to go through protocol design. I suck at protocol design, so it's probably not the best, but I basically made like a TCP-style protocol. Oh yeah, I mentioned some of this already. So DNS is pretty permissive. Like I said, you can put angle brackets through it, you can put quotation marks through it, you can put all kinds of crazy stuff through it, depending on the DNS server, obviously. All you're really guaranteed to work is letters, numbers, and maybe a couple symbols. Even that I'd be sketchy about. Letters and numbers is all I'm really comfortable with. So I actually wrote a base 32 or base 36 implementation, and it turned out to be like 2% faster than hex. So I just said screw it, I'm using hex. So you'll see like 60, 6F, 6F, discusslabs.org. Right now, there's no encryption, there's nothing like that. It's just pure plain text like this. Oh yeah, I do mention it. I started base 64, but OSX is stupid, so it didn't work. Oh yeah, I also mentioned base 32. Yeah, I wrote base 32 support on an airplane once, and it was complex and scary. 12% faster, not 2%. But yeah, either way, it wasn't worth the extra attack surface. So that's all well and good. I got this working. It worked great in my lab, using localhost. Dns Cat can talk to itself, and it was great. Tried in the real world, and it worked mostly, except not quite. So I would do a request like this, regular session. Once again, these all decode this thing funny. I don't remember what, but feel free to do that. So you would say, what's a TXT record? Here it is. TXT record, here it is, TXT record. Everything's working great until you say, give me a TXT record for blank. It's blank. Then you say, what's TXT record for blank? The server never sees it. It just gives a blank response. What's a TXT for blank? No response. I sat in a coffee shop for like 2 hours trying to figure out what was going on. It turns out caching. Even if you change the DNS ID value and stuff like that, your interim DNS servers will still try to cache things. If you set TTL to 1 second, it'll still try to cache things. It just, DNS doesn't, most DNS services are weird. So, fixing that was really easy. I just added a random field, a 16-bit random field every packet, which is meaningless other than it fixes caching. So the protocol has SYN, message, and fin. All right, let's do a demo. Cool. You okay for time? All right. So this window here, which is, I realize kind of hard to read. I apologize for that, but as big as it gets. So this window here is my server back home. It's the authoritative name server for sqlslabs.org. So if I was to, I'm not going to do that. But if I was to run like DNS logger on this, you would see all requests for sqlslabs.org would go to this server. Right now there's no DNS server running. So what we're going to do is we're going to run Dns Cache. So in the Dns Cache command line, you just give it the domain name to listen to. You can give 1 or 2 or 10 domain names. You can also give it none. If there's no domain name set, what it does is it'll only accept direct requests that go directly in port 53. If you give it a name, it'll accept the recursive requests. All right. So I tried to model this a little bit after Metasploit, or Meterpreter that is. So it gives you the command up at the top there, how to run Dns Cache on the client. I use an actual command line parser for all the commands, so you get decent help. There's all the commands you can use. You can get help on the commands, rather -h. It actually uses a command line parser built in, which is kind of neat. So on this laptop, I'm using this because it's Windows and it's a little bit cooler. For what's worth, this works natively on Windows and Linux, and probably OS X, and definitely BSD. So the client is in C, the server is in Ruby. It runs natively, it compiles with Visual Studio or with Make, and there's no dependencies. It's like Netcat. It should run everywhere. All right. So I'm going to run the client here, and what you'll see is the session pops up, new session established. And just for the fun of it, I'm not sure if I have it installed here, but if I do, look at that. Last time I did this talk, I made the mistake of, I did a test run, and I segfaulted on one of the things. I was like, crap, I screwed up something. So I spent like 2 hours in the hotel bar that night fixing it, and then the next day I forgot to do a git pull, and it crashed again. Anyway, this might take a while, so forget. All right, so we have a session established. I can run the sessions command, just like Interpreter or Metasploit, and say, I have a command session. That's the default session type. So I can interact with the session, just like Interpreter, and say, welcome to command session. Use help for list of commands. So this, I don't mention the slides, but this is using like a sub-protocol. Basically, it's like a protocol I wrote designed for, it's just like Interpreter's protocol, really. Someday I really should look at rolling this into Interpreter, because I think they'd be, they basically do the same thing. But you can do lots of things, but let's just jump right to it. Run shell. So what it's going to do is it's going to send the command to the server and say, please execute a shell. If it's Windows, it runs CMD. If it's Linux, it runs bash. So now I can run sessions, and it's going to say, now I have the session 1 command session and session 2 executing a shell. What the star means is that there's text there that I haven't seen yet. So I can interact with session 2 and say, hey, look, a shell. So I don't have a packet logger install on this machine that's worth using other than TCP dump, which is really boring for an audience. But I assure you that all the packets from this laptop to this one are going through the whole DNS hierarchy all the way through. So we have a shell, boring. You can see the speed too. Like, it's not as fast as native because everything has to be broken up into the size of a DNS packet. So you're going to see some delays. I actually did test this. I ran I ran basically cat/dev/u random through hexdump and let it go for a couple hours, and it all worked. I'm sure whoever runs the DNS servers were wondering why the hell there's so much extra data coming from Google, but anyway, not my problem. All right, so I can press Control Z, or Z as we say in Canada, to back out of a session. But they stay running, just like, once again, just like interpreter. It's my catchphrase here. So I can do that. I can run a second command shell here. If you give me 1 second. So I run it again, you get a third session established. Spelling is hard. So you'll see the third session established. Some data has come that we haven't seen yet. We can interact with it. You know, same deal. We can execute things. It's Windows, so actually I should have bash installed. So I say exec bash. I get a new session. Session 4 has been established. So I interact with session 4. Now I have bash. This is Sigwin for what it's worth. Anyway. So there you go. Back out of this. All right, one more thing, and this is the demo crashed last time, so fingers crossed. So I can, actually I'm going to first of all create a file. I know. Every single time. All right. Echo hi. That's wrong on Windows, I realize, but. All right. I can create a file, obviously. What's cool is I can download the file now from this. Actually, what's a little bit nicer demonstration is if I use session number 3, I can download. I know. Typing's hard. I can download the password file. Oh, error opening file. All right. Fine. One thing that's kind of cool actually that I didn't mention is on the command line you can still use up and down to use old commands. It's not Windows doing it, it's my program doing it. But anyway, the point is, you know, demos are boring. So you can upload files, you can download files, you can run a shell, and currently that's about it. So it's still early stages, but the tool works, it's stable, and I'm really happy with it. I really, yeah, okay. I'm going to put a link to it on Twitter and on my GitHub. It's on my GitHub page. I'm also happy with the current state, so I'm going to release like an alpha version and post that everywhere. If you guys could test it out, I'd super appreciate it. I'm sure there's bugs. A few future plans. Going to go through this real quick. So traffic forwarding. I would love, once this connection is established, to be able to forward traffic inside the network. Pivot through DNS. I originally, I think I have a diagram. Oh yeah, own the endpoint, open a socks proxy, profit. In my original version, DNS Cat 1, I tried to be everything. I should have talked about this initially, but it's too late for that. In the first version of DNS Cat, I tried to do everything. I tried to be a client, the client server of the same program. You can use it for, you're on an airplane, you want to connect to without paying, it would work. You want to use a hotel, whatever. But then I realized that's been done already. People have already written tools like Iodine to basically tunnel arbitrary data over DNS. So that's why I focus this more on pen testing, more on you have a shell, now what you do. You can, or you have a DNS, you have an exploit, now what do? You can open a shell, you can do all this kind of stuff. It's totally focused on pen testing though. It's got nothing to do with strep tunneling anymore. So what I could do, and I've written the code for this, and it kind of works, but I'm not comfortable yet enough to demonstrate it or to have it hooked up. But basically, you say, I want to open a port from the own client to 1.2.3.4 or 10. Whatever. on port 445. And then I want the server side, so my server on this laptop, to listen on port 1234. Then you can send a packet through port 1234, it comes out the other side on port 445, and basically tunnels everything through DNS. Basically a proxy for DNS. I also wrote SOCKS 4 proxy code to do this exact same thing. So you own a client, you install a DNS server or DNS client on there, and then you can browse the internal network through the DNS client. The code's there, I just haven't hooked it up yet. I don't like it enough. That's coming. Shellcode. Everyone loves shellcode. So right now, Dns Cache is only an exe file or a Linux binary file. And we all know that running binary files on other machines is difficult unless you use bash. So basically, you know what an exploit is. I don't have to go through this. But can we write a DNS payload? The answer is absolutely. I wrote a payload for Dns Cat 1 a couple years ago. The code is down there. Basically, I can use a whole Dns Cat protocol on Linux in about 950 bytes, on Windows just over 1,000 bytes. That's not great, but it's not bad for shellcode. But wait, there's more. So I wrote a stager. I wanted to see if I can get under 300 bytes, which was the size of the MS08067 payload size. And on Win32, I managed to get a DNS stager down to 232 bytes. Basically, it would send code. It would send requests to text records like 1.sqlslabs.org, 2.sqlslabs.org, until it got an X record. Basically, until it couldn't find it. Then it just ran whatever it got. Not secure whatsoever, but really simple, small stager. I forget about these things. All right. So the current status. Working hard to finish up stuff. This is a little bit old. I'm pretty happy now with the UI and with the last few things. But if you want alpha test and break stuff, the code is there. I think the last slide has it as well. And yeah, it currently compiles on Linux, Cygwin, BSD, and Visual Studio. And there's no reason it shouldn't compile OS X. I just don't have OS X to test on. So I'll have to grab a friend for that sometime. One more quick thing and then I'm done. So detection. I have one friend who does like the opposite of me. He like fixes stuff whereas I break stuff. And he always says like, you always do these talks, you never talk about how to prevent things. And I said, that's because prevention is boring. I'm sure any blue team people here are going to hate me for saying that, but I know, I like breaking stuff more than fixing stuff. But so anyway, detection is trivial. The thing is, you have to do it. If you see like a DNS request going every 1 second for the maximum size, something's going wrong. If you see like a megabyte over DNS in a day for one client, something's going wrong. Like, this is really easy to detect. That being said, that's the tunneling. The other stuff, like same with user agent and using that to find cross-site scripting, that's really, really hard to detect because all you see from a company is a failed DNS request. And yeah, happens every day. So yeah, log DNS traffic. If you're on a prevention team, log DNS traffic and look for weird stuff. Yeah, and that's pretty much all I have. So